Hi, I'm G, and in this recitation video, we're going to be covering a thermal expansion problem. Here it is. So in this problem, we're given at a steel beam 14 meters in length. The initial length is allowed to expand by 2 centimeters, which means that the delta L in our length expansion equation is 2 centimeters, or 2 times 10 to the negative 2 meters. We're also given that it's steel. That means that alpha is going to be 11 times 10 to the negative 6, 1 over degrees Celsius. Now the bar is initially at room temperature, or 75 degrees Fahrenheit. The initial is 75 degrees F. And we want to know that if the maximum of length expansion is 2 centimeters, what is the maximum temperature that this bar can have as to not exceed that 2 centimeter limit. And we want that to be in degrees Fahrenheit. So this problem begs us to use the length expansion equation that delta L is L initial times alpha times delta T. However, this delta T must be in degrees Celsius, and we're given temperature in Fahrenheit. So before we can go ahead and use this, we'll have to convert our initial temperature from Fahrenheit to Celsius. And so just as an aside, the Fahrenheit temperature is 9/5. The Celsius temperature plus 32, which means that the Celsius temperature is 5/9. Fahrenheit temperature minus 32. So we find out that T initial, which is 75 Fahrenheit, is about 23 degrees Celsius. And so expanding this equation, knowing that delta T is T final minus T initial. T initial is now in degrees Celsius. We can go ahead and solve for T final. Here's delta L. So I'll divide by alpha L initial and then add that initial T over. So we'll have delta L over alpha L initial is equal to, plus T initial is equal to T final. So with delta L as 2 centimeters, the initial length is 14 meters, and alpha as 11 times 10 to the negative 6, we should get a T final. This is 2 times 10 to the negative 2 meters over 11 times 10 to the negative 6, 1 over degrees Celsius. That's 14 meters plus 23 is equal to 153 degrees Celsius. So this would be right, except they asked for a final temperature in degrees Fahrenheit, and that begs us to use the conversion from temperature in Celsius to temperature in Fahrenheit. So T final is going to be 9/5, 153 plus 32, which if you plug into your calculator, you get, just say it, what is it?
309.
309. 309 degrees Fahrenheit. Box that, and you'll be good to go. Thanks for watching.
Because it's too late.